Hello everyone. In this video, we will learn to determine equations of a split function, voltage versus time. A split function may have more than one equations and in different time intervals. Split function is also called the discontinuous function. All waveforms are periodic. Periodic means that a function will repeat itself after one period. When the time interval is not given to us, we have to examine the waveform and recognize when the wave repeats itself to figure out the period of the waveform. Before we begin, we need to identify the points on the time domain that given to us. So the unit for this time domain is the capital T, which is the period for this graph. So what I will do, I will identify the point on the time domains. So if I have t here, right here, I should have t over 2. Okay, right here, I should have 3t over 4. Right this point, I should have t divided by 4. And here is 0. So this point should be negative t over 4. Alright, okay. So let's take a look at this pattern for this wave. The pattern for this wave, if you look at closer, you can see that it will start from here. Right? It will start from here. It's come up to the Vmax. Okay, so right here is my Vmax. And from the Vmax, it dropped down to the negative Vmax. So right here, you see that is the negative Vmax. So this point that I'm talking about. So you go to negative Vmax. This one is the positive Vmax. So if I trace this pattern again, I can see that the function actually split right here. That means it's discontinuous at this point. Okay, so from here you can recognize that the first interval for this function should be specified as negative t over 4 to t over 4. Okay, so that's one period. So what I have is I will say t is less than t over 4 and greater than or equal to t over 4 as negative. Okay. Then I trace the pattern of this waveform again. I starting from the Vmax, like I said. It will stop at the negative Vmax. And then it's coming up again to the positive Vmax. So this function actually repeats itself after the period of negative t over 4 and 3t over 4. So what we have here is only one interval of this function. The other interval of the function, I should indicate it as t will be greater than or equal to t over 4 and less than 3t over 4. Okay, so that means all of this here will cover the period of this waveform after this one period, starting from negative t over 4 to 3t over 4, this waveform will repeat itself. However, most of the time, you will see that the time interval will be given to you. In this case, it's not given to us, so we have to identify the repeating pattern so that we can calculate the slope. And after we get the slope, we can pick the point so that we can fit it into the equation to find the equation for this waveform. And don't forget, it will be two equations in this case. So each of this time interval that we found right here will have one equation associated with that. Okay, so let's get started. before I continue with the points, I would like to do some review for everyone here. To find the equation of a straight line, we begin with finding the slope. Okay, so we find slope equal to y2 minus y1 divided by x2 minus x1. In this case, we are not working with x and y, we are working with the voltage and time. Okay, but we still write m equal to y2 minus y1, x2 minus x1, and then we will replace y with the vt, and we replace x with the period t here, and then the time domains. Okay, so let's write the equation again. To find the equation of a straight line, we are going to use the point slope form equation. So that means y minus y1 equal to the slope that you just found, and you put x minus x1. Okay, so let's put this as a reminder, and we will get back to this. Alright, so in order for me to find the equations, I need 2 points, right? I need 2 points. So the easiest point that I will use is this point right here. So I will use 0, 0, and I also use this point. So this point, what I have to write is, I should write it as when t equal to t over 4, then v will be equal to v max. Okay, so I will use this 2 point in order to find the slope for this particular line. Okay, so keep that in mind. I will find the equation for this line within the period of t over 4 and negative t over 4. So I'm using that 2 points, so I will identify that. Okay, so I will write it as 0, 0, and then I write t over 4 and v max. So I identify this one as my, here is my x1, y1. Here will be my x2, y2. Okay, so what is the slope? The slope, m equal to y2 minus y1 divided by x2 minus x1. So y2 is v max. Subtract y1 is just 0. x2 is t over 4, and subtract 0. So we are having v max divided by period t over 4. Therefore, it's v max times 4 over the period t. So I should have 4 v max divided by t. So this is the slope. So the slope is equal to this. Okay, so with the slope equal to that, I can go ahead and I can substitute that into the equation of y minus y1 equal to the slope of x minus x1. Okay, so in this case, I will have y is actually my vt. Okay, y1 is equal to 0, which is this point that I identify there. y1 is equal to 0. Now, equal to m, which I already found. So I will write it as 4 v max divided by period t, and I multiply by x, but x is not the domain that we are using. We are using t. So I am going to identify that as t minus the x1. In this case, I identify that up here, this point that I use is equal to 0. So I put 0. So I will have vt equal to 4 v max divided by t as period multiplied by t. So this is the equation for the periods of t as we identify up here. Okay, will be less than t over 4 and greater than or equal to negative t over 4. So this is one equation for the split function. That's the first one that we found. Okay, so how about the other part of it? So let me go back to the figure that we have, to the graph, and I will trace my graph again. Okay, so the next one is this green line that we are talking about here. So it will repeat itself again, coming down here and stop. So that means I have to identify this within this time intervals. Okay, which we already identify in this case. Okay, so like here what we have, t will be greater than or equal to t over 4 and less than 3t over 4. So what point do I choose? On this graph, I only have this point to work with. So what I will do is I will choose this point so that it's easier. Okay, easier because I will have a 0 in it. That's what I mean. Okay, so I will have time domain as t over 2, and then for vt that should be equal to 0. So we should write down those 2 points, and we will use that to figure out our next equation for this waveform. Alright, so t over 4 Vmax and t over 2 0. Okay, so I will write down 4 t. Okay, so in this case, for t greater than or equal to t over 4 or less than 3t over 4, I will use the 2 point of t over 4 and Vmax, and I will use t over 2 and 0. Okay, so let us identify the x1, y1, x2, y2. So in this case, we make it x1, here's y1, here's x2, here's our y2. Okay, so we start with finding the slope, m equal to y2 minus y1 divided by x2 minus x1. So I should have y2 is 0, subtract y1 is subtract Vmax, and x2 is t over 2, subtract x1 is period t divided by 4. Okay, so the numerator I just have negative Vmax, but the denominators I have to subtract these two by finding the common denominators. So it will be 4t over, actually it should be 2 over 4. Okay, so I multiply both of this by 2. So that's just make a note here, multiply by 2, multiply by 2. So I should have 2t minus t divided by 4. Okay, then this will give me negative Vmax divided by t over 4. Okay, so that means slope is equal to negative Vmax multiplied by 4 over t. So in this case, I should have negative 4 Vmax divided by the period t. So the slope for this particular line in this time interval will be negative 4 Vmax over t, which is true, because if you have the straight line facing this way, okay, then your slope should be a negative slope. Alright, okay, so after I have this, what I will do is, again, we write down that equation that we need, y minus y1 equal to slope times x minus x1, but we have to make sure that we put that in terms of vt and t. Okay, so I will write vt minus y1. y1 in this case is Vmax, so minus my Vmax. Okay, and here I will have the slope, which I just found, negative 4 Vmax divided by period t, and inside the bracket x in this case should be t, and what is the x1 in this case? X1 is actually equal to t over 4. Okay, so there's quite a few algebra that we have to be careful here. Alright, so my next step is I will multiply this inside the brackets. Okay, so I will have Vt minus Vmax equal to, so multiply this in the bracket, I should have negative 4 Vmax divided by this, multiplied by T, and now you see that negative times a negative will give me a positive, so I will immediately write positive here. I will have 4 Vmax divided by period T, and I time that with period T divided by 4, and I know that I can simplify some term here, that and that cancel out, and that cancel out. So what I have left is, I should have Vt subtract Vmax equal to minus 4 Vmax divided by period times time, and for this term I just have Vmax left, so plus Vmax. Okay, so writing this equation, I should write Vmax equal to, and I will bring this one over to the side, bring it over, turn into a plus. Okay, so Vmax over T times T plus Vmax, adding the Vmax again. So this 2 adding, I should have twice the Vmax. So in the end, my equation will be Vt will be minus 4 Vmax over period T times T plus twice the Vmax. Okay, in conclusion, you see that you must have 2 to work with, okay? 2 equations to work with for this particular waveform because it's discontinuous. So for this period, I should write it as for T is this period that I should write, okay? So T less than 3T over 4 greater than or equal to T over 4. Alright, okay. So let's continue with the next question. The next question I have for everyone is determine the equation of split function again, voltage versus time, but in this case we are having a square wave. Okay, the previous one is a triangular wave. This one we have a square wave. So this is actually very simple. Okay, very simple. So let's take a look at the period that we have. This is the time domain T. The period here is T. The purpose of this question is to remind everyone that to recognize the pattern of the waveform, how it actually repeat itself. Okay, so let me trace this for you to show you how it repeat itself. So let's say I start with the Vmax. My function will go like this. Okay, a straight line going down and then meeting the negative Vmax and there. Okay, so the function repeat itself by right here. Okay, so now I recognize that a period for this function would be from 0 to t. So, but I already identified that for everyone over the cycle of t greater than or equal to 0 and less than the period t as we identify. Okay, so to find the equation for this, what you do is you will look for the point where the function is discontinuous. So in this case, it's right here. Alright, so the period will divide it into 2. So in this case, I should have t divided by 2 in here. Okay, so it means from 0 to given t greater than or equal to 0 and less than t over 2, my function would be just equal to Vmax. So Vt will equal to Vmax. Okay, so that means I'm talking about this particular period. Okay? Yeah. Alright. Now, the next one is we are talking about this part, this period from there to there. Okay, so that means I'm going to write t greater than or equal to t over 2 and less than the period t. Then in this case, the vt will be equal to just a negative vmax, because right here you see that you have a negative vmax. Alright, okay, so if you check, you see that t greater than 0, less than t over 2, and then you repeat it as t greater than period t divided by 2 less than t. If you add this 2, it's actually equal to the full cycle that you have. So the functions kind of repeat itself after the period t, but in this one cycle, you will have two equations for this particular square wave. Alright, I have two more questions to go over with everyone, but I think it's best that I stop right here and I continue with the next lesson. It's because I could only record one lesson, maximum one lesson is 30 minutes, and I don't want to go over that. Alright, so we have two more questions to work with, so I will leave it for my next video. Okay, thank you everyone.